All right, I think we're okay. Yeah, Frank just kind of like poofed into the ether and disappeared entirely from my streaming platform. So, no, you don't have to do this. Excuse you. We did. What was it? Right? Yeah, the panel and thing. Okay. Check you before you wreck you. About half of these, you had to do that GCF business. Remember, you had to take a GCF out first, and that was write down all your factors. What do they have in common? Don't forget your kid brother at Burger King. Okay. Remember, the order does not matter just as long as the terms and the signs are good. Yep. Now, I'm a little concerned that across the board we seem to be batting about 500 in terms of kids who actually did it. We had like a half hour in class to work. And especially when you say, nah, we're good, we're going to get it done. Nah, I'm going to do it in Spartan time. Well, I'm going to do this at home. That way I have something to do. And then you don't. You ain't sitting over there again. Okay? You ain't hanging out with that person again during work time. Okay? I'll put you over there in the corner and have you just nicely stare at the wall. Y'all. Algebra ain't going to get any easier than this. I pare it down to the absolute bare bones of what you need to move on to geometry. And then we don't have homework. We do it all in class. You have 2 teachers in here to ask questions in addition to working together. And if you still are going to dink around playing pool and whatever, being on socials, instead of getting it done, then maybe we just need to put that away for the remainder of the semester so you actually pass the class.
I'm passing this class.
So, now that we've thrown a lot of shade, any questions on these? For those that did them. 13? Okay. 13 had some big honking numbers on it. So, off to the side, you were going to have to break these up. We've talked about divisibility rules in here before when we were doing section 4.2. Does it end in a 0, 2, 4, 6, or 8? I know it's not divisible by 2. Does it end in a 0 or a 5? Not divisible by 5. There's a rule for 3s that says if you take the digits and that number is divisible by 3, then so is the big number. Or you can just grab a calculator and say this divided by 2. Nope, doesn't work. This divided by 3. Oh, hey, cool, it works. Okay, so we break these up, prime factor style, and we say this is 3 by 121. That's on my list. I go to 108. First thing I do is break it up with a -1 and a 108 so I don't forget my sign. I say, well, it's divisible by 2. I know that much. 54. Oh, hey, that's on my chart. I know that. That's 6 times 9. That's 2 times 3. That's 3 times 3. What? Oh yeah, I moved it. And you say contestant 1 is 3 by 11 by 11 by double x. And contestant 2 has got a lot of stuff going on. Negative 1 by 2 by 2 by 3 by 3 by 3. What do these guys got in common? Just a 3, nothing else. So we circle our 3. Threes. And if I take that 3 out, whatever's left here tells me what's left inside my parentheses after I divide by it. 11 times 11 is 121. X times x is x squared. 2 by 2 is 4. 3 by 3 is 9. 4 by 9 is 36. And now that I've cleaned it up a little bit, now that I took out that GCF, I go look at my perfect squares, those yellow numbers diagonal on your chart, and it says, oh, hey, both of those are. Square root of this is 11, square root of that is 6. Plus minus pair, but don't forget your kid brother at Burger King. Okay? But you're not going to see the 121 and the 36. You're not going to see the perfect square numbers until you clean it up. And about half of the problems on this page were like that, where you had to take a GCF out first. Okay? We're going to see that again today. That GCF is kind of a big deal. That's why I'm willing to take my time in Chapter 4, because GCF and factoring and multiplying, pretty common thing in geometry when you're looking at side lengths of things. They'll say like the side, I'm putting fence up to make a new dog pen, and the side of this is, and they give me an expression. And the side of this is, they give me expression. And then, okay, go do geometry stuff with it. You can't do that if you don't know how to do the algebra. Okay? That's why we're practicing so much. Any of those other ones? The words weren't too bad, because it was blah, 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 the same thing, right? Just like that kind of plywood panel looking one that we did as an example. Big thing minus little thing. Whole panel minus the part you cut out. In fact, this kind of representation is used in other stuff in algebra to do completing the square. I know there's a couple of you that are headed to the regular algebra class next semester or next year, and you will see that again as a visual description of completing the square. Okay, it's a pretty common math trope. Only one vocabulary term, and then if you got stuff separated by a subtraction sign but they're not perfect squares, I was playing with my metal detector, beep, 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 I found something, I pick it up and it's just a lump of like rusted crud. You got to clean it off. I see a binomial, I see a difference, but they're not perfect squares. Clean it up. Get rid of that junk on it. Okay? So we went through the things. You know what comes after going through the things. I know this is out of order, 7. Difference of squares. I would like you to factor go. Also, no one took me up on my offer. Well, one took me up on my offer on Tuesday. Y'all, it is Maroon Day. It is a Spartan time. If you owe me tests, get them done. Okay, there's a handful of you that owe me quiz 9. Unfortunately, there's 1 or 2 that still owe me quiz 8. And then 10 we just did on Friday. So if you are missing quizzes, get your booty down here during Spartan time and let's get some math on. Look at your perfect square list. If it's not on there, gotta take out a GCF first. Get your GCF out of there, if there is one. Look for perfect squares. Plus, minus, pair. Is that enough time, or are we still going? A little bit. Okay. Good. Okay. I'm going to try something different up here. I'm working with someone the other day where instead of writing things out horizontally like we've been doing, we did it vertically. And just made more sense to them, so I'll see if that works here. Off to the side, I'll say 98. I'll break it up as 2 by 49, 7 and 7. What if I wrote it like this? 2, 7, 7, x, x. Does that freak us out after doing them horizontally? I'll run through it and then I'll just write it again, okay? But, okay. And then negative 128 was negative 1 with 128. 2 with 64, 8 and 8, 4 and 2, 2 and 4, 2 and 2, 2 and 2. If you look at the ends of the branches, that just got a lot of 2s. Poke and poke and poke and poke and poke and poke and poke. Because it's a power of 2. And that, I said, I said it's a lot of 2s. I'm not going to poke the negative 1. It's not a 2. Like yesterday, the other class, they finally got their brownies. The first time all year, the White Day crew has gotten brownies. I'm so proud. They've grown up. Yes, I do. Trying to punk me in my own class. So, got negative 1 by 2, 4, 8, 16, 32, 64, 128. Okay? So, you'd break them up and you'd write out all of their factors. Now, what do they have in common? Not a whole lot. What do they got in common? Just a 2. So if I circle just a 2, get that out of there. If I take a 2 out, then everything that's left gets multiplied together. 7 by 7 is 49 by x by x. Two, 4, 8, 16, 32, 64 with a negative. So this is where I think if you wanted to try this vertically, it might be okay for you because then you kind of see the numbers like falling down into those 2 spots. It's just a different method of organization, right? If you had yours horizontal like we've been doing, you're still cool, right? You circled your 2s. So, that ain't done. Now I say the square root of this guy is a 7x. And the square root of that one is a 8. And I make it a plus minus pair. Don't forget your kid brother Burger King. Okay? Forgot your kid brother Burger King, didn't you? Dude, mom's gonna be mad. Okay. Point-wise, did you get to the 7x's? Did you get to the 8's? Did you write it as a plus-minus pair? Did you remember your kid brother? And then, back here, I'm going to leave one floating for if you maybe goofed up the factoring part of it, or maybe you missed a sign on something. I don't care. Shush. No one asked you, Siri. So, something out of 5, go ahead and mark it. And then we'll move on to the next section. Yeah, it is. Dude, you left Ian at Burger King. That was like 4 hours ago. Yes, that's a point. Okay. Made kind of a big deal about that yesterday. If you factor something out, it doesn't just disappear. You just set it off to the side. Forgot it on the second. Pulls up to his driveway. Mom's outside looking mad. Where's Ian? All right. I think I have this labeled as 4-6, but it's 4-8 in the packet. I think I did that because then 4-8 is the stuff I added at the end about quadratic formula. So whatever. Just cross out 4-8 at the top, call it 4-6, just so we don't get confused later. So over here you got this blank space, and just like we did last time, I want you to factor some stuff for me. I would like you to factor let's do x squared minus 12x minus 64. Nah, not minus 64. Let's do plus 64 plus 20x. There we go. Got that little blank space there. I would like you to factor this. Just like we were doing before, find all the factors of 64, and then which of them add up to 20. Go! Got a calculator? You got a chart? Get your math on. I was up 4 times last night. And the only sleep I got was drooling on my kid's carpet floor. Sucks trying to do school stuff when you're tired. I think the generation that stays up till 2 in the morning playing games and scrolling socials knows that more than anyone. Y'all have to take care of yourselves. Okay. Go down the list. We know 1 times 64, that's an easy one. Does 2 go in there? Does 3 go in there? Does 4 go in there? Does 5 go in there? Just keep going down the list until it starts repeating itself and you found them all. I got a grand total of 8 possibilities. That includes changes in signs. 8 times 8 is a different critter than negative 8 times negative 8. There you go, double positive or double negative to make a positive 64. I said a grand total of 8, and that includes sign changes. You find them? Well, find them all, because then I'm going to go messing with it, dude. Over here trying to shortcut things. Yeah, you're right for this, but look at all the space on that board. I'm going to do things to it. Okay, just like we did the other day. I am currently looking for what times what makes a positive 64, but they add together to make a positive 20. Off to the side, I write out all the ways this is going to happen. We know 1 times 64 makes 64. I always say don't forget the does, right? But if 1 by 64 works, what else does? Okay, double negative. Does 2 go in there? How many? Okay, and if 2 and 32 work, then double negative works. Does 3 go in there? I'm not sure what to make of that sound. I heard just kind of an Oh, okay. 4? And then double negative. 5? 6? You sure? Okay. 7? And then 8 and 8 with a negative 8 and negative 8. Okay. Those are the factors that make 64. Go look for their sums so we can find what the magic pair is. Get a 65, negative 65. 34, negative 34. 20, negative 20. 16, negative 16. Who gets the chicken dinner? Okay. Winner, winner. 4 by 16 and 4 plus 16 is the magic combination, so I would write that out as, I would not write it out as that. I'd call that x plus 4 and x plus 16. And when I multiply those out, when I distribute, whether you're going to use your arrows or FOIL or box method, whatever your jam is, it should come out with a positive 20 in the middle when you combine like terms. So what happens, remember yesterday, I got rid of the middle term. Or not yesterday, 2 days ago. I got rid of that middle term. And it turned out they were all of a special form. Did anyone notice that there's a 1 and a 64, and those are perfect squares? Especially after doing all those perfect square problems. Now, I'm going to say x squared plus 16x plus 64. I didn't change much. I just changed the middle term. There is still a middle term. But look at who the winners are. Look at which ones make this true. I still have this idea of there being special factors when they're squares. Not always. Sometimes I don't get just the square root of 64. But there are times where I do, where the square root of 64 is 8. 8 plus 8 happens to make 16. And instead of calling this x plus 8, what did we call it when I did something times itself? Like if I said x times x, squared. This has a special format of x plus 8 squared. I would square root this guy and put it here. I'd square root that guy and put her there. Can you look at what's different from this one to this one and make a prediction of how that works? What's the only difference between those? I heard someone mutter it. This is why I said write out all your factors. A positive 8 and a positive 8 makes the positive 16 in the middle. A negative 8 and a negative 8 makes the negative 8 or negative 16 in the middle. So I can square root this dude, square root that kid, and then whatever the sign is stays. Square root this, it's another special form. Yesterday, or 2 days ago, we were doing special forms with squares. Now we got a different special form of squares. Okay? How many terms did I originally start with? The very beginning problem. What's that called? Trinomials. Last time it was perfect squares with binomials. This time it's perfect squares with trinomials. They're not always going to be a special format, but a good chunk of the time they will. These perfect squares do a lot of good things for us. So, come on, Frank. Go, Frank. So, what they're saying is, I got this middle term now, and these are perfect squares. If I can write this as x times x, and I can write this as 7 times 7, I just got to make sure that if I add those two together, or if I take 2 times 7, it'll make this middle term. So, verify the middle actually makes that. Does x times 7, and then 2 of them, x times 7, 2 of them, I'm going to do this twice, make me a 14x. Will I combine a 7x and a 7x to make a 14x? Yeah! Cool, that means I found my special form. That means this is square root of this dude, square root of this dude. Double check that the 7s will add up to this. You just got to double check that. If they don't add up to this, then you go do your normal factoring stuff we did last week. But if they do add up to this, you get cheater form that says, well, I just said x plus 7 twice, so I'm going to go x plus 7, and then they have that squared there. Okay? And I write it special like this. Just like last time, I wrote x plus 7, x minus 7 to make x squared minus 49. I saw the perfect square, I saw the perfect square. I did the special thing with it. Now I'm going to see the perfect square and see the perfect square. I got to double check if I can do the special thing with it. And then I write it that way. They say to check this. If I have x plus 7, the quantity squared, that means I'm taking an x plus 7 times an x plus 7. I'm doing that twice. Make those parentheses a little bit bigger for you. You see why we spent so much time on all that distribution business. That's how we're checking all these. It's how we're doing them. How we're making sure we're right. I get an x squared. I get a 7x. Green. I said green. A 7 with an x and a 7 with a 7. Do any of these terms go together? Do we got like terms? Do we have a turtle with a turtle? Mm-hmm. A 7x plus a 7x is a 14x, which is what I started with. X squared plus 14x plus 49. I win. But my answer was this. Okay? They're not always going to be special like that, but we have the potential to do less work if we recognize the special form. Okay? Think about just playing a game. It could be playing a video game with your buddy. It can be being on a sports team. Okay? If we go against this team, we know that they're just running to the right because that kid always goes to the right because that guy can block and that guy can't. If you're playing your one buddy, you know that if they have this character, they're going to run to this part of the map because they want that particular weapon, right? You know these things about your opponent. You know if you play a certain someone in Scrabble that they never get the I, E, and C rule right. So, if I see perfect squares, I need to be aware that there is a potential special version of that. Okay. Oh, no, it's the same thing. Yeah. This is really big. Come on, Frank. So, I see something factor. I look at my first and last terms and I see they're perfect squares. So, let's do square root of this guy. I know that's a 5x times a 5x. Do square root of this guy. It's a 4 and a 4. I just got to double check. If I take 4 times 5x, and if I do that twice, because when I distribute, I'll end up with 2 of them, does all this junk multiply together to make negative 40? Five x times 4 is 20x. Double. 40. But this was a negative 40, so I just know that I need to have a negative with my answer. Instead of saying 5x plus 4 and 5x plus 4, I'm going to say 5x minus 4 and 5x minus 4. Because negative 4 times negative 4 still makes a positive 16. I wrote the same thing twice. That means I get to just say that thing squared. Ta-da! I win. Just a special form. Now we double check that this actually works. If I have a 5x minus 4 squared, that means u. 5x, a minus 4, a minus 4. Got to get the colors all nice and separated here so we can see what's going on. And I say 5x times 5x. 5x times negative 4 is negative 20x. Negative 4 with 5 is a negative 20x. And negative 4 with negative 4 is plus 16. Turtles with turtles, giraffes with giraffes, any of these combined together. Yeah, 20 and 20. So 25x squared minus 40x plus 16, I got all the way back to where I started. And again, if you don't like the variables that they use, maybe instead of using x's, they use t's in there. As long as it ain't a formula, change it. Make yourself more comfortable. That's really it. That's the bulk of this. Can you recognize these perfect squares? Can you double check that they will indeed make that middle term? Sometimes they do, sometimes they don't. We're just showing you examples when they do. All right. Let's go. Tegan. I gotta do one of them. Which is it? Okay. We'll try to go through a little bit faster this time. Here's my problem. I see that these are perfect squares. I know this is x times x. I know that's 11 times 11. I just got to double check that if I take x times 11 2 times, will I actually get this middle term? 2 times 11 is 22. 22 times x is a negative 22x, which is what I was looking for. Okay? I just got to double check that works. If that works, then I get to just write it as square root of this guy is x. Square root of this guy is 11. I just write that as a double negative now. So end of the problem is x minus 11 squared. Because I said it twice, and I'm dropping things because we're that exhausted. Okay. That's it. Yeah?
So, I know this isn't like, but on number 2, is that supposed to be a 10x? Like on the paper it says 10x, but it's supposed to be 10x. Supposed to be like that?
Oh, do they have a goof? I ain't taking credit for their errors. I stole this curriculum fair and square. Good catch, 10. Over here on number 2, turn that 10 into a 20. How's their goof? We don't get credit for that. Yeah, like 10 years ago. Okay, everyone see on number 2, changes to 20x. All right, 1, 2, and 4. Give them a whirl. One, 2, and 4. Look for those perfect squares. Have your multiplication chart out, or maybe you wrote that perfect square list out. Oh. Multitasking.
Yeah.
Attaboy.
So would this be maybe 2 or 8? They both
The
same one.
square root of this is x and x.
Yeah.
The square root of this is
8 and 2. Oh, let's go. 4.
4 and 4.
Oh, snap.
You are way too young to be sighing that exasperatedly. You got to get a little bit of arthritis before you can have that kind of irritation at the world. Okay. Yes, sir. Did you do it right? You absolutely did, but you can always check it instead of asking me. Take x plus 4 times x plus 4. X squared. 4x. 4x. 16. I got the x squared. I got the 16. Do those add up to 8?
Yes.
Winner, winner.
Chicken dinner.
Okay, got it. That was the saddest round of applause I've heard in a while. Don't use that Mr. business on me. It makes me feel weird. Okay.
So, I mean, I kind of looked at this for the bottom, and I kind of just copied it from every other one. But
No, we're going to be getting rid of like 90% of this pretty quick here. Because square root of this, square root of this, keep the sign.
oh, nice.
Right? We're going to get rid of this pretty quick here. You just have to double check. Does 2 of these make this? Yes.
So, okay.
We got to double check because sometimes it doesn't. Sometimes you'll see x squared minus 8x minus 9. Or x squared minus 10x plus 9. So I'd say, all right, square root of him, keep the sign. Okay, did 2 of these make 10? No. Oh. Well, I guess it's not the special one. I got to go do it for real. Okay?
Alright, yeah. Is that kind of all it does?
Yeah. Now,
That's
we might, yeah, we might have to watch out for maybe a little bit of GCF business. Okay. There might be some other stuff with it, some shenanigans. But that is the core of it, yes. Okay. Yeah. Mm-hmm. to make this big. Whoop. Okay. You recognize a square. You recognize a square. So you square root this guy and you square root that guy, getting x and 4 respectively. You just need to double check, does x times 4 and then 2 of them actually make this middle term? And if it does, that means it's one of the special ones. If it's one of the special ones, then that means I get a double x, I get a double 4, right? Don't applaud Frank. He should not receive encouragement for this. Now, I'm just working with Sean here, showed you the short version of this, right? Y'all, we're about to take most of this away because we don't need to do all of these steps. I can see these two are perfect squares and say, all right, square root of this guy, square root of that guy. Keep the sign in the middle. I just have to double check. Frank, why are you being this way? I just have to double check that 2 of these will actually make 8x. Does it? Cool, that's my answer. Done. Okay, this is just the check. Okay, down here, I take this by this and I get this special form. I don't need to write all this out if I just recognize my perfect squares and the form. Frank? Why are you leaving scratches on my board? I don't know if anyone besides Leslie can see those. Like it looks like I just straight up wrote on it with a pencil. And I realize I'm just totally doing the mom and dad thing right now of like, let me get that for you. Yeah. All right. Go a little faster. I see a perfect square, I see a perfect square. So x by x and 10 by 10. We said that was a 20. I double check. Will x, a 10, and doubling that actually equal a 20x in the middle? Yay, it does. Since it does, I get to write that exact same thing. Boop. Where the square root of this guy goes here and here. Right. And the square root of this guy goes here and here. Keep the sign in the middle. If there was a plus in the middle, I have x plus 10. If there was a minus in the middle, I say x minus 10. And what was the other one? I did 3. Frank? Y'all, what is it until finals? 15, 16, 17, 18, 19 school days if we include today. 19 days until I'm done with you, you giant sack. All right. So let's try this again, except now we got some bigger numbers. Same thing, it's just bigger numbers. If you recognize right away that this is a perfect square, the square root of this is 4x. If you recognize right away this is a perfect square, it's on that diagonal yellow list, then the square root of that is 7. I just have to double check that a 7 times a 4x, what is 7 times 4x? 28x, double it. What's 28 times 2? It better be 56, but y'all better check it too. Okay, so it works. I get the magic number. I get the 56x in the middle, which is what I was trying to find. Since this is a square, they really do multiply and double to make this. That means special form time. I get to put my 4x here. I get to put my 7 over there. And now I know that I can write it as this plus this squared. Okay, it's just done. That's it. That is the special form. Now, down here we've got to go check it, make sure we didn't screw anything up. If I say 4x plus 7 and I square it, that means I've got a pair of them. Boop, boop. We have a 4x plus 7 and another 4x plus 7. We're going to go to distribution town and say first outer inner. I ain't done yet. Last. Do any of those combine? And 28 plus 28 is starting to develop a reasonable credit score. 56. Okay. Oh, no, back up. Shoop! 2 more to try. Bigger numbers, go! Little bit bigger numbers, same process. Yep.
Okay.
2 of this times this. In fact, in algebra, that's a mental math trick to doing these, is multiply and double. Yep. So in the middle, they want to confirm that if I multiply these and double it, does it work? Yep. What you got?
I need help.
Don't break it.
Well, is this on your list? Is that a perfect square? Okay. So, I got a 2x and a 2x. Is this a perfect square? Okay. Now we just need to confirm.
Why do you have 2 9s?
If I put 2x times 9,
You told me to do this.
what's 2x times 9?
So 18x.
That's what you
Double
told
it.
me to do.
Because there's only one X and we're getting those X's.
36.
Is it?
Well, there's 2 X's.
Yeah.
Because there's an X on the front and an X on the back.
18. Yeah, 36x.
Okay.
Oh, so not put an X
Yeah.
Yeah.
I'm
So
right.
you got this in the middle.
or tiny.
That means that this is the way you do it. It's going to be a 2x with a 9, a 2x with a 9, which means a 2x with a 9. It's just because this had a minus, these got to be minuses. Because I said the same thing twice, then I get to say it's just that thing squared. Boop.
Alright.
Same thing. Mm-hmm.
You stay.
I like
Correct
a
one.
method down. Like a
Like,
pretty
did
close.
I at least get it somewhat right? I feel kind of iffy about it.
Negatory.
Negatory.
I mean, the right pattern,
I feel like it's
but
no.
we completely missed that we have to square root this.
Yeah.
Okay.
What's the square root of 4x?
2x.
Or sorry, 4x squared.
2x squared. Oh.
So a 2x and a 2x.
Okay.
What's the square root of 81?
Oh, 9. I was looking at the wrong problem.
And then I have to double check. If I have 2x times 9 and double it, will it actually make 36?
2x plus 9.
2x times 9,
I don't know. It's like
double it.
cutting my fingers.
Oh, wait, alright. I hate this game. Hold on. Time. Get it down. Okay. 2x times 9.
Times another 2.
Okay.
Maybe you should.
So that means this is the way that I'm going to do it. I will have a 2x with a 9 and a 2x with a 9. Both negative because this was negative.
I was 2 away.
If I just said the same thing twice,
I want to apologize.
that means I just say 2x minus 9 squared.
So that's what we're doing here, too?
Mm-hmm.
Okay. I understand this game.
Okay. Yes, ma'am.
Need help, Mr. Curtis? You know what you're doing over here?
I'm struggling.
Okay. So, round 1.
Where did you? What?
I don't know. You told me to put that, so I put it.
You don't just write random things, child. Okay.
Yeah, we broke up the 2x
So-
and we had 9 and 9.
Square root of this guy. 2x, 2x. Square root of this guy. 9 and 9.
Yes.
I have to double check when I multiply those two things. When I multiply these, what's 2 times 9?
18.
What's 18 times 2?
36.
So since we do actually get this guy in the middle, that means these are the right numbers. I can write a 2x a 9, a 2x a 9, but I keep the signs. I have to keep the same sign. Hey, look, I just said the same thing twice. Since I said the same thing twice, I'll just say that thing squared. Just make sure that you're keeping the sign. Okay? Same thing here. Square root this, square root this. If I multiply and double, do I actually get 42? If I do, then it's special. And I get to write the special thing. Okay.
Thank you.
Mm-hmm.
Prison. For this one.
Flip it over. Okay, just checking.
Like, so 48, because nothing can go into it evenly. Like,
No, you're right. You do square root of this guy, bam, bam.
24.
Square root of this guy, bam, bam.
Would that be 2 and 2? Right.
If I take 4x times 6, what do I get?
24.
Now double it.
Okay, so I'm going to go back.
Okay. So because that works, this is the check to make sure that it's one of the special guys. It's like, I don't know, IDing someone at the counter. Like, are you sure? And then it finds out, okay, yeah, this checks out. So I put a 4x with a 6. I put a 4x with a 6. I don't know why they have a random 4 here.
That's a.
Oh, I know what they do. I know what they're doing. Hold on.
When I get rid of the extra steps, it's kind of confusing. I like doing like all the
I get what they're doing.
Because I'm guessing you just put a 6 here.
Okay. Here, I'm going to make an extra step. Okay.
Is that what they want you to do?
This says plus, we say plus. They skipped a step. Because I just said the same thing twice, I can go to 4x plus 6, the quantity squared. Don't these two still have something in common? 2. These two got something in common. And these two got something in common. So what they're saying is, if I pull a 2 out of this guy, and I pull a 2 out of this guy, this divided by 2 is 2x. This divided by 2 is 3. This divided by 2 is 2x. This divided by 2 is 3. And it's the same thing. So I can write it like this, or 2 times 2 is thing times thing is thing squared. It's kind of weird. I'm going to do that by GCF off to the side. I'm going to do it 2 different ways. All right. You should have. I look at the trinomial and I see that's a perfect square. Why are you still doing that? It's still on there. It's like the end of that pen got rubbed in charcoal or something. Okay. Oh, no, I just lost my whole problem. Burp. I dropped them all on the floor. Let's try this again. Oop. Oop. All right, square root of this guy. 2x. Square root of this guy is 9. What I have to double check is if I take that 9 and I take this 2x and I multiply them together and then double it, do I get the term I'm supposed to? So I go 9 times 2 is 18. 18 doubled is indeed 36. Okay, sometimes we just coincidentally get there. Because of that, that means I can just write the same thing twice. I can write a 2x plus a 9 but then I double check my signs. Remember, the signs always have to match. Is it 2x plus a 9 or is it 2x minus a 9? Okay, since they used a minus here, I need to use a minus here. Since I just said the same thing twice, I can just write that thing squared. Okay? So it all boils down to that basic process. Square root of this guy, 7x. Come on, come on, come on. Square root of this guy. 3 and 3, write it over here. Then in the middle, take 7 times 3 and get? No. Is what? 21. Double it. If I double 21, I do indeed get what I was aiming for. I get a 42. Since that works, I know that I can write a 7x both times, and I can write a 3 both times. I just have to double check that my signs match. If this says plus, then these need to say plus. If I just said the same thing twice in a multiplication problem, that means I can just say that thing squared. Ta-da! Okay, flip it over and we get a weirdo. Frank, you're really holding the show here. Frank, you're holding up the show. Frank gonna get a chair through the face pretty quick here. All right. Same thing we were doing before. But something weird gonna happen at the end. I start with this guy's a perfect square. What? Okay. This guy's a perfect square. Double check. If I put a 6 here and a 4x here, what's 6 times 4x? Double it. Yay! Where we might get confused is look at the next round. They got a 4 hanging out. I don't like that they did that. I'm going to add an extra step in here. Okay? I'm going to add an extra step in here. Let's scribble this 4 out for now. Okay? And just do what we were doing before, and I'll add one more line underneath it. We have a 4x plus 6. I said the thing twice, so that means I get to say the thing squared. So why did they have those 4s there? Look at what these two still have in common. 4x and 6. What's a factor that goes into both? 2. Okay. So if I take a 2 out of this guy, 4x divided by 2 is 2x. 6 divided by 2 is 3. Frank. Same thing, right? A 2 and a 2x plus 3. Remember that multiplication is commutative. The order that I do it doesn't matter. So what if I took the two things out of parentheses and smushed them together? What's 2 times 2? 4. And what is a thing times that same thing again? Like, for example, x times x. We'd say it's squared. So since it's this thing times this thing again, I will say 2x plus 3 squared. Do you see how right here I could have taken out a 2, but I took out 2 of them because it was squared. That's why there's a 4 in front, because I could take that 2 out of them twice. Now, Sean ran into this because he was running ahead. And that didn't quite make sense until you start talking about GCF. (16x squared plus 48x plus 36). Frank, get with the program. If I were to write all of these out, 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. 48. 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. And then an x. 36, 2 times 8. 2 times 18. 18 is 2 times 9. 9 is 3 times 3. Our GCF factoring that we just got done doing a whole bunch of, what do these have in common? Two 2's. So if I take this out of all of them, what is 2 times 2? 4. Leaving 2 by 2 is 4x squared. 2 by 2 is 4, by 3 is 12x. 3 by 3 is 9. And then if I were to say something like, I don't know, square root of this guy is 2x. Square root of this guy is 3. 2 by 3 is 6. Double of 6 is 12. This is one of my special guys. Keep the sign in the middle. Don't forget your kid brother at Burger King. Okay? You could just take out a GCF and then do the special factor. All right? Now, the word thing is blah, 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 do the same business. But I would rather save that for next time to get us going again and then have you get some time to work. Okay? So, we'll bump things down the line a little bit. Next time you'll have time to work on this, and then we will start quadratic formula.